Okay, so now let's solve the following problems. We have problem number 1. The siren of a police car at rest emits a predominant frequency of 1600 Hz. So that is F. What frequency will you hear if you are at rest and the police car moves at 250 meters per second toward you, and then B, away from you, if the surrounding air temperature is 32 degrees Celsius? So let us solve first the velocity of the sound. Okay, let's have velocity of sound as affected by the temperature. Okay, so you have here again velocity equals 331.5 plus 0.6 times the temperature, which is 32 degrees Celsius. So the answer for that, 331.5 plus 0.6 times 32 is equivalent to 350.7 meters per second. So that is now the velocity of sound. Now let us solve for the frequency if the police car moves toward you. So you have here, formula is F prime equals F over 1 minus the velocity of source divided by the velocity of sound. So let us substitute. The frequency emitted by the police car is 1600 Hz divided by 1 minus the velocity of the source is 250 meters per second divided by the velocity of sound is 350.7. So solving that one, you will have a frequency which is equivalent to, so this is again towards the listener, so the frequency is 5,572.19 Hertz. So you can see here that this frequency is higher than 1600 Hertz. So it emits a high-pitched sound. Okay, so now let us solve the second part wherein the police car now moves away from the listener. So you have frequency or frequency prime. The frequency which will be heard by the listener is equivalent to if it's moving away. So we have F over 1 plus the velocity of source over the velocity of sound. So substituting it, we have 1600 Hertz divided by 1 plus the velocity of source here, we have 250. Then again, the velocity of our sound, we have 350.7. So solving that, you will have a frequency equivalent to 934.11 Hertz. So you can see here now that we have a lower frequency if it is now moving away from the listener. Okay, so that is for problem number 1. Okay, so next problem we have, when an observer moves at 15 meters per second towards an automobile, he hears a frequency of 5.5 Hertz. So if he hears that frequency, that means that is F prime, or the apparent frequency. What is the frequency that the horn actually emits? Assume that the temperature is 20 degrees Celsius. So let us solve first again for the velocity of sound. So you have velocity of sound v equals 331.5 plus 0.6 times the temperature is 20. So for the speed of sound, we have 343.5 meters per second. Okay, so that's the velocity of sound. Now let us solve for, we are looking for the frequency actually emitted by the horn. So we have a formula. If the observer moves, we have a formula wherein we have f prime equals 1 plus the velocity of the observer divided by the velocity of sound multiplied by the frequency. But we are looking for this. So let's derive f now is equal to f prime divided by 1 plus the velocity of the observer divided by the velocity of sound. We now have f is equivalent to, the frequency heard is 5.5 hertz divided by 1 plus the velocity of the observer is 15 divided by 343.5. So the original frequency emitted by the horn, so let's substitute 5.5 divided by 1 plus quantity 15 divided by 343.5, you will get 5.27 hertz. So you can see the 5.27 hertz is lower compared to the apparent frequency, which is 5.5 hertz. Since the observer is moving towards, therefore the observer will also hear a higher frequency sound. Okay, next. Okay, let us now compare the shift in frequency if a 2000 hertz source is moving toward you at 15 meters per second or also moving away from you at 15 meters per second if the surrounding temperature is 26 degrees Celsius. So again, let's solve first for the velocity of sound. You have here velocity of sound 331.5 meters per second plus 0.6 times the temperature, which is 26. Okay? So there, solving for that, you will get 347.1 meters per second. So let's solve first yung A, if it's moving toward you. Our formula for that will be f prime is equivalent to f divided by 1 minus the velocity of source divided by the velocity of sound. So let's just substitute. We have, for the frequency, it's 2000 hertz. So you have here 2000 divided by 1 minus the velocity of source here is 15 divided by 347.1. So our final answer after substituting this, you will get an answer of 2090.33 hertz. Since it's now moving towards, therefore you can expect that the frequency which will be heard is higher. So that's 2090, which is higher than 2000 hertz. Okay? So let's solve for the second part. Okay, B, if it's moving away, so you have frequency, apparent frequency is equivalent to F the actual frequency, 1 plus the velocity of source divided by the velocity of sound. So let's substitute again. We have 2,000 divided by 1 plus the velocity of source is 15 divided by 347.1. So the answer for this one, 2,000 divided by 1 plus quantity 15 divided by 347.1 is 1,917.15 meters per second. Okay. So again, you can expect that this will be lower compared to the actual frequency emitted by the source, which is 2,000 hertz. Okay. Next item. Railroad train is traveling at 30 meters per second in still air. The frequency of the note emitted by the train is 262 Hz. What frequency is heard by a stationary listener? If the velocity of the wave is 350 meters per second. Okay, let's check if, for example, the listener is stationary but the train is moving towards the listener. So we'll have again an equation. Since given ang velocities of sound, we don't have to calculate for it. So we have frequency prime equals frequency divided by 1 minus the velocity of source over the velocity of sound. Okay? So just substitute, you have 262 Hertz divided by 1 minus ang velocity of source natin is 30. Then divided by 350 meters per second. So the answer here is 286.56 Hertz. So this is the frequency of sound the listener will hear. So it's at a higher frequency, so higher pitch. Okay, so let's solve. A police siren emits a wave with frequency of 300 Hz. The speed of sound is 340 meters per second. The siren moves away from the listener with a speed of 45 meters per second. And the listener is moving away from the siren with a speed of 15 meters per second. So they are both moving away from each other. What frequency does the listener hear? So let's have the formula now. We are going to use a formula wherein they are moving away from each other. So that is F prime is equivalent to the velocity of sound minus the velocity of the observer or the listener divided by the velocity of sound plus the velocity of the source. Okay. So we have here, for the velocity of sound is 340. So that's 340 minus the velocity of the observer. It's okay, the velocity of the observer here, the siren moves away from the listener, so that's the car, and then the listener is moving away. So we have 15 divided by 340 plus the velocity of the source, which is 45, times or multiplied by, sorry, you have to write here, kulang to, it should be multiplied by F, okay? So multiplied by, the frequency is 300 Hertz. Okay, there. So let's try to answer this one. That one is equivalent to 253.25 Hertz. Okay? So last item. A railroad train is traveling at 30 meters per second in still air. The frequency of train whistle is 262 hertz. What frequency is heard by a passenger on a second train approaching the first train? So they are in opposite direction. The speed of sound is equivalent to 350 meters per second. They are approaching each other. So let's have a formula. F prime. And let's now have the formula F prime is equivalent to F multiplied by the velocity of sound plus the velocity of the observer or the listener divided by the velocity of sound minus the velocity of source. So you have here frequency emitted is 262 hertz multiplied by the velocity of sound given here is 350 plus the velocity of the observer is 18 divided by 350 minus the velocity of source, which is 30. So let's solve for the final answer. Okay, so the answer now is 301.3 hertz. Okay, if they are moving towards each other. Okay, now I'll give you an additional problem solving on this, which is not found in the module. So I'll just give you an extra worksheet in solving for problems on Doppler effect. Okay, so if you have any question, just send me a message. Bye, everyone.